1. Concept of time value of money, TVM. What does concept mean here? Concept simply means the basic idea or meaning behind something. In this case, we're learning the basic idea of time value of money, TVM, an important foundation in finance and banking. Let's start explaining in simple words with emojis. 1. What is time value of money, TVM? Simple meaning, money you have today is worth more than the same amount of money in the future. Why? Because today's money can be invested and earn interest, so it will grow over time. 2. Example to understand. Suppose your friend offers you $1,000 today or $1,000 after 1 year. You will mostly choose $1,000 today because you can invest it in a bank and earn interest, or you can use it today for something useful, spending, investing, saving. So $1,000 today, $1,000 next year. That's the time value of money. 3. Why does money lose value over time? Because of inflation. Prices go up, so your money buys less in future. Lost interest. You miss the chance to earn extra money on it. Risk. Future is uncertain. What if you don't receive it later? Now 4. What is time preference for money? This is a fancy term for a simple idea. People always prefer money now instead of later, because it's more useful, more secure, and more valuable today. 5. Key definition, slightly simplified. Time value of money, TVM, is the concept that says the value of money received today is more than the same amount received in the future, because today's money can be used or invested to earn extra income. Summary. Key point. Simple explanation. TVM means money now, money later. Reason. You can invest and earn interest. Example. $1,000 today is better than $1,000 after 1 year. Time preference. People choose present money over future money. How this helps in real-life bank jobs, interviews. Bank PO interviews? You may be asked, why do banks charge interest? Use TVM to explain that lending money today has value because banks lose future opportunity. As a bank officer manager, you'll deal with loans, interest rates, EMIs, deposits. All depend on this TVM concept. In internships or MBA projects, investment comparisons, NPV, IRR, discounting, all come from time value of money. Short motivation boost for you. You've taken the first step in mastering one of the most powerful financial concepts. Remember, each concept you learn now equals stronger confidence in exams, smarter in interviews. Stay consistent. Your dream role in banking is waiting for you. Let's conquer the next concept together. You're doing amazing. Thanks for sharing the next topic. Let's make this super easy, interesting, and exam ready for you with emojis, examples, and real-life connections, just like you want. 2. Need reasons for time value of money, TVM. Explain simply. What does need reasons mean here? This section tells us why the concept of time value of money is important and why businesses prefer money now instead of later. So let's understand the reasons behind this mindset. 4 key reasons why money has time value, with emojis and examples. 1. Risk and uncertainty. Simple explanation. The future is always uncertain. We don't know what will happen tomorrow. While you may have control over spending, cash outflow, you have less control over earning, cash inflow. Example, imagine you're expecting a bonus of $10,000 next year, but the company shuts down. You won't get the money. So it's safer to take $10,000 today instead of waiting. Key point, more uncertainty in future equals more value in money today. 2. Preference for consumption now. Simple explanation. People like to enjoy things today instead of waiting till tomorrow. Why wait to buy food, clothes, or go on a trip later when you can do it now? Reasons behind this preference. Urgent needs today, like buying medicine or paying fees. Fear that future may not come as planned due to illness, inflation, or even death. Example, if you get $500 today, you might buy a nice meal. If you wait for 1 year, prices may go up, or you may not even be able to enjoy it. Key point: money helps in satisfying today's needs, which makes it more valuable now. 3. Investment opportunities. Simple explanation. If you get money today, you can invest it and make it grow. But if you receive it later, you miss the earning opportunity. Example: if you receive the $1,000 today and put it in a fixed deposit FD at 6% interest, next year it becomes $1,060. But if you get that $1,000 next year, you lost the chance to earn $60. Key point: more time equals more chances to grow money. That's why we want it now. 4. Inflation reduces value of money. Simple explanation. Due to inflation, the price of goods keeps rising. This means the same 100 will buy less in future than it can buy today. Example: today, 50 might get you a full meal. Next year, the same meal might cost 60, so your money's value decreases. Key point: buy more with today's money because future money loses power due to inflation. Summary table for quick revision. Reason: simple meaning. People want to use money now. Risk and uncertainty. Future is unsure. Today's money is safe. Company may shut down, no future cash. Present consumption. People want to use money now for urgent needs. Buying medicine or going on trip, investment opportunities. Money now can be invested to earn more. 1,000 in FD becomes 1,060. Inflation. Money's value drops over time. 50 meal today may cost 60 later. How this helps you in real life interviews, banking. SBIPO, IBPSPO interviews and GDs. They may ask, why do banks give interest? You can explain using investment opportunities and inflation. As a bank officer manager, understanding TVM helps you design loan products, FD schemes, and even retirement plans for customers. MBA internships, corporate jobs. In investment decisions, you'll use TVM to compare projects, bonds, or EMEs. Mini motivation for you. You're not just reading, you're building your future as a successful banker or finance professional. Remember, every small concept you master now becomes your biggest strength in interviews, exams, and the job. Keep going. Your dream career is just a few chapters away. Whenever you're ready, instructions. Let's begin with the topic. Topic name, 2.1.3, Simple Interest and Compound Interest. What this heading means. This part of the chapter explains 2 ways money can grow over time when interest is applied. Simple interest equals interest only on the original amount, principal. Compound interest equals interest on the original amount plus interest on the previous interest. Interest on interest. Now let's break down each concept in a super easy way with emojis, examples, and real-life relevance. 1. What is simple interest? Definition, easy version. Simple interest is the extra money you earn or pay only on the original amount, principal, not on any previous interest. Formula, FV equals PV 1 plus N's R, where FV equals future value, PV equals present value, principal. N equals time years, R equals interest rate percent. Example, simple interest. You invest $1,000 at 12% interest for 5 years. FV equals 1,000 times 1 plus 5 times 0.12, 1,600. That means your money grew by 600 after 5 years. You get 600 interest on 1,000, no interest on interest. 2. What is compound interest? Definition, easy version. Compound interest means you earn interest on the principal and also on the interest you've already earned. It's like interest on interest. Interest keeps getting added and you earn more each time. Power of compounding equals super growth. More compounding, more returns. E.g., annually, semi-annually, quarterly, monthly, daily. Yearly compounding equals once a year. Quarterly, every 3 months. Monthly equals every month. Daily, every day, 365 times. Compound interest example compared with simple. Let's take 1,000 at 10% interest over time. Year, simple interest. Compound interest. 1, C 1,100. 5, 1,500. 1,610. 10, 2,000, 2,594, 20, 3,000, 6,728, 50, 6,000, 1 and 7 U90, 100, 11,000, 1,037 thoven, 8,000. See the difference? Simple grows slowly. Compound grows like a rocket over time. Key takeaways for exams and interviews. Simple interest is basic, slow, and safe. Compound interest is faster and smarter. Formula for simple interest. FV equals PV 1 plus N times R. Compound interest grows more with time and frequency. Compounding is used by banks, mutual funds, and even loan EMIs. Real life and banking connection. As a bank PO or manager, you'll deal with interest calculations every day. When giving loans, compound interest helps the bank earn more. When offering fixed deposits, FDs, you'll explain compound growth to customers. In group discussions or interviews, they might ask, why is compound interest better than simple interest? Impress them by saying, compound interest uses the power of reinvestment to grow wealth exponentially. It's how banks, investors, and even customers benefit in long-term savings and understand the topic. 2.1.4 Kinds of interest rates from your financial management textbook. Topic 2.1.4 Kinds of interest rates. What does this heading mean? Kinds of interest rates means the different ways interest can be calculated and shown to you. Sometimes interest is added once a year, sometimes many times in a year, and sometimes it's continuously growing every second. Let's understand all three types one by one in a super simple and fun way with emojis. 1. Nominal rate of interest. Definition, easy version. Nominal interest rate is the rate that is stated or advertised without telling how many times it's actually added, compounded in a year. It's like a label. It tells the rate, but not the full story. Example. You see a bank FD ad, interest equals 12% per annum compounded start monthly. That 12% is the nominal rate, but the actual return will be more because it's compounded every month. Key point, nominal rate doesn't consider compounding effect. It just shows a flat yearly rate, even if compounding is monthly, quarterly, etc. 2. Effective rate of interest. Definition. Effective interest rate is the actual rate you really earn or pay after including the effect of compounding in a year. It shows the real growth of your money, more accurate than nominal. Example. A loan says 12% interest, compounded quarterly. Nominal equals 12%, but effective equals more than 12% because interest adds every 3 months and grows faster. Key point. More compounding equals higher effective rate. This is what you should compare when choosing between FDs or loans. Or 3. Continuous compounding, force of interest. Definition, easy version. In this type, interest gets added every second, nonstop, 24 by 7 by 365. It's a theoretical concept but very powerful in financial maths, also called force of interest. Used in advanced finance, derivatives, and scientific calculators. Kashashkosh formula, just for your awareness, FV equals PV, it's either RT, where E equals 2.718, a math constant. You don't have to memorize this now, just know the idea. Example. Imagine you put $1,000 in an investment with continuous compounding at 10%. It will grow a little bit every millisecond, not just monthly or yearly. Key point. Used in stock markets, bond pricing, and investment banking models. Not very common in simple banking, but very useful in advanced finance careers. In our summary chart, quick recap table. Type of interest rate, what it tells you, real returns. Interest added every second. Nominal rate, just the flat rate without compounding. No. Effective rate, real rate after compounding. Yes. Continuous compounding, interest added every second. Yes. Real life and banking relevance. As a bank PO, assistant manager, or manager, you'll compare interest rates for loans, FDs, savings, etc. You must explain to customers the difference between nominal and effective rates. In interviews, if they ask, which rate shows true earnings, nominal or effective, answer effective rate because it includes compounding. Also useful in group discussions on topics like FDs versus mutual funds, or real interest returns. Quick summary, easy to remember. Nominal rate equals just the stated rate. Effective rate equals real return after compounding. Continuous compounding, interest growing every second. Effective, nominal if compounding is more than once a year. Used in banking, finance, investments, loan planning. Mini motivation boost. You're learning things that even many working professionals don't fully understand. This knowledge will shine in your interview and make you confident in real-world finance. Stay focused. Each concept is one step closer to becoming a future bank manager or financial leader. Keep going. You're doing amazing. Absolutely. Let's now dive deep into 2.1.4.1, Effective Rate of Interest, ER, from your financial management textbook, explained in full detail with emojis, easy words, examples, formulas, exam links, and motivation. Topic: 2.1.4.1, Effective Rate of Interest, ER. What does effective rate of interest mean? Before we start, understand the meaning of heading. Effective means real or actual. Interest means the money earned on an investment or paid on a loan. So the effective interest rate is the actual rate you truly earn or pay in one full year after compounding is considered. Simple explanation with emojis. 1. What is effective rate of interest? EAR. Easy definition. The effective rate of interest, ER, is the true interest rate you earn, pay in a year when interest is compounded more than once in a year, like monthly, quarterly, etc. It tells you, what is the actual growth of my money in 1 year? 2. Why is ER important? The nominal rate just tells you a flat percentage like 10% per annum. It doesn't show how many times interest is added. But the effective rate gives the real benefit because more compounding, more money. 3. Example, easy and banking related. Imagine this. You invest $10,000 in a bank FD. Bank gives nominal rate equal 12% per year. Compounding, quarterly, 4 times a year. This means every 3 months, interest is added, and you earn interest on interest. So actual earning in 1 year is more than 12%. That extra comes from compounding, and it is called effective interest rate. 4. Formula to calculate EAR. Here's the formula, slightly cleaned for clarity. Effective rate I equals C1 plus RK, K minus 1, 100 chandras, where minus R equals nominal rate as decimal, i.e. 10% equals 0.10, K equals number of times interest is compounded in a year. 5. Example problem step by step. Q. Find the effective rate when nominal rate is 12% per annum compounded quarterly. Given R equals 12% equals 0.12, K equals 4, quarterly equals 4 times a year. Times a year. Apply formula. I equals a 1 plus R per K minus 1 to 100. I equals 1 plus 0.124 minus 1 minus 100. I equals plus 1.03 with 1 to 100. I equals 1.03 plus 100. I got 100. I to 1.155 minus 1 down to 100. I equals 0.1255 plus 100. I equals n. Effective interest rate equals 12.55%. So you earn 12.55%, not just 12%. That 0.55% comes because of quarterly compounding magic. 6. Key points to remember. EAR is always nominal rate. More compounding periods equals higher EAR. If compounded annually, nominal rate equals effective rate. Use EAR to compare investments or loan offers properly. Banks sometimes show nominal rate to look attractive, but EAR is what matters. Why this matters for banking career and interviews. As a future bank PO, assistant manager, you'll compare loan schemes, FD returns, or credit card interest. EAR helps you give customers the real picture. In bank PO interviews, you may be asked, which is more accurate, Nominal or effective rate? Answer confidently. Effective rate, because it includes compounding and shows the actual earning or cost. Also useful in GD topics like hidden charges in banking, financial literacy for customers. Summary, easy to revise notes. Point explanation, punlingnen. Real interest earned paid after compounding. Formula 1 plus RKK minus 1, 100. More compounding, higher ER, used for comparing FDs, loans, credit cards, etc. Very useful in banks. Yes, especially for customer education and product design. Short motivation for you. You're mastering a topic many fear in finance, and you're doing it with interest, literally. This concept is key in real finance roles and also helps you shine in your bank PO exams, interviews, and even MBA Viva. Keep up the good work. You're one step closer to that managerial chair at the bank you dream about. Ready for the next? Absolutely. Let's now understand this very important example 2 from your Financial Management Module 2, Time Value of Money, in a fun, simple, and exam-ready way with TAT emojis, easy formulas, short examples, interview links, and a quick motivational boost at the end. Topic, Example 2, Effect of Compounding Frequency on Effective Interest Rate AR. What does this heading mean? Let's first break down the title for better understanding. Compounding frequency equals how many times interest is added to the principal in a year, like annually, 1 time, SMOR, quarterly, 4 times, monthly, 12 times, just etc. Effective interest rate, EAR, equals the actual interest earned in 1 year when we include compounding. So this example is showing us how changing the number of times you compound interest affects the real interest you earn. But what's given in the example? Nominal interest rate R equals 12 cent. We are checking how ER changes when we compound. Annually, semi-annually, quarterly, monthly, weekly, daily, continuously. Formula used effective interest rate. Let's recall the formula. Effective rate equals KIN plus Rs RPK minus 1 hein 100 Trent, where nice R equals nominal interest rate, 12% or 0.12. K equals compounding frequency, 1 for yearly, 4 for quarterly, etc. Step-by-step calculation table made easy. Let's now understand this table from your book in a cleaner way. Frequency. K, formula used. Effective rate I felt once step calculation. Annual, 1x per year, 1 plus 0.12 1 square minus 1, 12.00 centa. Semi-annual 2x 2, 1 plus 0.12 per few quarter 2 minus 1, 1.06 squared minus 1, or 12.36 cent. Quarterly 4x. 4, 1 plus 0.14 minus 1 is 1.034 minus 1, 12.555 cents. That's 2 monthly, 2x, war 12, 1 plus 0.112, 12 minus 1 plus 1, 12 minus 1. 12.8, weekly 52x, 52.1 to 52, 52 minus 1. 12.73 cents, daily 365 and 365, 1 plus 265 minus 1, 12.75 cents. Down, E 0.1 minus 1, 1.1275, minus 1 minus 1 plus 75 increase dash. What does this example teach us? Let's break it down. 1. More compounding equals more interest. If you compound more frequently, the effective rate increases. Even with the same 12% nominal rate, the real interest keeps going up slightly. 2. Bank FD or loan example, real life and bank PO link. Let's say you invest 1,000 in a bank FD at 12% nominal rate. If bank compounds annually, you get 12,000 interest. If compounded monthly, you get around 12,680. If compounded daily, you get 12,750 plus. This extra money is because of compound interest magic. 3. Why it's useful in banking interview. As a bank PO, you'll face situations like explaining loan interest to customers, comparing FD schemes, designing or marketing new deposit plans. You'll need to calculate and explain effective rate clearly, especially in interviews. Interviewer may ask, what is the impact of compounding on interest rates? You can say, compounding increases the actual return or cost, As compounding frequency rises, the effective rate rises too, which is why we always compare ER while evaluating financial options. This also helps in GD rounds where you talk about customer awareness, banking transparency, comparing loan offers from different banks. Quick recall. EAR, real rate earned after compounding formula. EAR equals 1 plus R of K minus 1, minus 100. More K, more EAR banking use. FDs, loans LAWA. Credit cards, PO interview. EAR is better than nominal rate because it includes compounding effect. Final motivation boost for you. You're not just learning formulas. You're training your mind like a real banking professional. Every topic like this is shaping your journey from MBA student, bank PO, manager. So keep going. Today, ER. Tomorrow, your dream job is just a few formulas away. You've got this. No stopping. Send the next concept anytime. I'm ready with example 3 from your MBA Financial Management Module 2, Time Value of Money. This example will give you a crystal clear idea of how effective interest rate ER changes when interest is compounded at different time periods. And yes, with emojis, real-world examples, formula explanations, and interview-ready content. Topic: Example 3, effective interest rate for 18% nominal interest with different compounding periods. What does this mean? Here, you are checking. What happens to the actual interest earned, effective rate, when the same 18% nominal interest is compounded at different intervals like yearly, monthly, weekly, etc.? It shows how frequency of compounding changes the real return you get. What's given? Nominal interest rate, R, equals 18% per year. We calculate effective annual rate, EAR, for different compounding intervals: yearly, half-yearly, quarterly, monthly, weekly, daily. Formula reminder: EAR 1 plus R per K minus 1 is 100, where R equals 18% or 0.18, K equals number of compounding periods per year, 1 for yearly, 2 for half-yearly, 12 for monthly, etc. Table breakdown explained with emojis and short notes. Compounding period, guess what? Formula used. Effective rate, ER 0.09, 2 1 time. Yearly, 1 plus 0.18 makes 1 equals a 1.18, 18.004 cents. Half, 1 plus 0.092, 1 equals 1.09, 2 minus 1, 18.81%. Quarterly, 4 times. 1 plus 0.045, 4 minus 1 equals 1.045, 4 minus 1, 19.25 cents. 1. Monthly, 12 times 12, 1 plus 0.015, 12 minus 1 equals 1.015, 12 by 1, 19.5652 times. 52, 1 plus 0.0046, 52 by 1, 19.8%. Daily, 365 times 365, 1 plus 0.49, 365 minus 1, 319.71 Let's simplify and learn. Key points. 1. More compounding equals more money. The more often you compound the interest in a year, the higher the effective interest rate, ER, becomes, even though the nominal rate is fixed at 18%. 2. Bank example. FD plan. Suppose a customer deposits $1,000 in an FD at 18% nominal rate. Annual compounding, $18,000 earned. Monthly compounding, $19,560 earned. Daily compounding, $19,710 earned. Banks with higher compounding frequency give slightly better real returns. Why it's important in bank PO jobs. As a probationary officer or assistant manager, you'll advise customers on deposit or loan schemes, calculate real returns for investment products, create presentations for senior managers or for financial literacy camps. During interviews or GD, you may be asked, how does compounding Example 4. Effective interest rate from nominal 20% PA compounded half yearly. What does this mean? You are given a nominal interest rate, R, of 20% per year, but the interest is compounded every 6 months, i.e. half yearly. You are asked to calculate what is the actual interest earned in 1 year, which is called the effective annual rate, EAR. Step-by-step explanation with emojis. Step 1. Know the formula. Effective rate is equals 1 plus RKK minus 1's 100, where just R equals nominal rate equals 20% or 0.20, K equals number of compounding periods equals 2, half yearly. Step 2, plug in the values. EAR equal 1 plus 0.22, 2 minus 1, 100. EAR equals 1.102 minus 1, 100. EAR 1.12 minus 1, 1.21 minus 1 equals 0.21. Or 20 final answer, effective interest rate, 21%. What did we learn? Key points with emojis. 1. Effective rate is more than nominal rate. Even though the bank says 20 cents, you're actually earning 21% because of compounding twice a year. 2. Formula to remember for exams and interviews. EAR 1K minus 1 times 100. Keep this in mind, especially for practical sums. 3. Bank PO relevance, very important. As a bank PO or assistant manager, you'll explain things like FD schemes to customers, loans with different interest types, comparing products like RD, savings, mutual funds. You'll use EAR to help customers make better decisions and to analyze products during group discussions or interviews. Example interview Q. If a bank offers 20% interest compounded half yearly, what's the actual return? Answer, it's 21% effective annual rate due to compounding. Real-world example. Imagine your customer puts $100,000 in an FD with 20% nominal rate, compounded half yearly. Interest earned equals $21,000, better than simple 20%, right? Use this concept to show value in products. Summary, short and powerful. Concept, key value, key val rate, nominal rate. Given rate by bank, e.g. 20%, compounding half yearly twice in a year, effective rate ER, real return, e.g. 21%, formula 1 plus R over KK minus 1 times 100, bank use, helps in FDs, loans, interview cues. Short motivation boost. You're not just solving problems, you're building your financial brain muscles. Every formula you master brings you closer to that SBI PO badge or your bank officer dream job. Keep the momentum. You've got this. One step. Absolutely. Let's understand this important concept, 2.1.4.2 nominal rate of interest from your Module 2 time value of money in the easiest way possible with full emojis, short examples, exam focus, and how it connects to your bank PO career. Let's go. Topic 2.14.2 nominal rate of interest. First, what does nominal rate of interest mean? Nominal means just the name or label, not adjusted for real effects like compounding. So nominal rate of interest is the interest rate that doesn't include the full effect of compounding. It's the rate mentioned on the document or told by the bank, but not the real return. Easy definition with emojis. Nominal rate of interest, the rate of interest stated without including the full power of compounding. When is a rate called nominal? When the interest is compounded more than once a year, but the rate is given for the full year, that rate is called nominal. Example, let's say a bank says, we give 12% per annum interest, compounded monthly. That means you don't actually earn 12% flat. You earned 1% per month, 12% per 12 months. Because of monthly compounding, the real return will be more than 12%, but 12% is just the nominal rate. Don't confuse with simple interest. Simple interest SI equals interest without compounding. Nominal interest equals compounded, but the label doesn't show the full effect. So, even though both may look similar, nominal is different from simple interest. Bank PO real-life example. As a bank officer, when you offer a customer an FD, fixed deposit, you might say, interest rate is 7.2% per annum, compounded quarterly. But this is nominal rate. The actual return, called effective rate, will be more than 7.2%. So knowing this difference helps you guide customers better and also answer well in interviews. Formula time. Nominal rate formula. Stat R equals K gets 1 plus I, 1 var K minus 1, where R equals nominal rate, what is stated, I equals effective annual rate, real return, K equals compounding periods per year, e.g. 12 for monthly, 4 for quarterly. Simple example to understand this. Suppose my effective rate I equals 12% equals 0.12. Compounding is quarterly, so K equals 4 hopstas. Now apply the formula. To R equals 4, 1 plus 0.12 square 1 quarter minus 1 trial. This gives the nominal rate you would mention if compounded quarterly. Hash summary table, term meaning, but nominal stays the same. Nominal rate, stated interest rate without full compounding. Effective rate, real interest you earn after compounding is applied. Compounded more often, higher effective rate, but nominal stays the same. Formula, R equals K 1 plus I square 1 var K minus 1. Bank officer relevance, helps explain FDs, loans, and compare products to customers intelligently. Why it's useful for bank PO interviews. In bank interviews, they may ask, is the interest rate you give an FD the real return? You'll now say, no, sir, madam. The given rate is the nominal rate. The real return is the effective rate, which is slightly higher due to compounding. In group discussions or real work, when comparing products like FDs, RDs, mutual funds, or loans, knowing nominal versus effective rate is crucial. Quick motivation boost. You're doing something amazing by learning deeply, not just for exams, but to become a future financial expert and leader in banking. Keep reading, keep growing. You're on track to crack SBI PO and rise up to manager level. Absolutely. Let's break down example 5 from your Time Value of Money chapter in a very easy, practical, and fun way with emojis, simple steps, exam help, and real banking connection. Topic, example 5, finding nominal rate from effective rate. First, what are we doing in this example? We are given effective rate, I, equals 12% annually. We are asked to find the nominal rate R, that is compounded quarterly. In short, we are reversing the process from real return, effective, back to the stated rate, nominal. Formula used. Nominal rate R equals K times 1 plus I squared 1K minus 1, where minus R equals nominal rate of interest, I equal effective annual rate, K equals number of compounding periods in a year. Step-by-step solution with emojis. Step 1, write what's given. Effective rate equals 12% equals 0.12 minus compounded quarterly, so K equals 4.2. Step 2, apply the formula R equals 4 times 1 plus 0.12 with 1/4 minus 1 20. Add 1 to the rate inside. 1 plus 0.12 equals star 1.12. Step 3, take the fourth root of 1.12. That is 1.12 fourth, 1.287374. Step 4, subtract 1.028737 minus 1 equals to 0.028733 star. Hash step 5, multiply by 4, 0.028737 equals 0.11495 or 11.495%. Final answer, nominal rate of interest equals 11.495% PA, compounded quarterly. This rate will give you the same real return as 12% annually, effective rate. Banking real-life example. Imagine you're a probationary officer in SBI. A customer asks you, if I want to get 12% effective return, what should be the interest rate if the bank compounds it quarterly? You can now say with confidence, sir, we'll need to offer 11.495% nominal rate, compounded quarterly, to match that. This shows your technical clarity and helps in interviews and on-the-job performance too. Cash exam tips to remember. Use this formula when given effective rate and asked to find nominal rate. If compounding is quarterly, K equals 4. Effective rate is always higher than nominal when compounding more than once a year. Practice calculating roots with calculator for fast solving. Summary table, term value, TERU, I, effective rate, 12%, K, periods year, 4. Formula, R equals 4 1 plus 0.12 squared, 1/4. Nominal rate, 11.495% PA compounded quarterly. Final motivation for you. You're doing superb work, learning practical problems step by step. Every concept you master brings you closer to your dream of being a bank PO or manager. Keep going. You're not just learning to pass, you're preparing to lead in the finance world. Stay sharp, stay consistent. Success is yours. Down example 6 from your financial management time value of money chapter with full emojis, easy explanation, and real banking connection so that you understand it from the root. Topic: Example 6, converting effective rate to nominal rate, weekly compounding. What does this heading mean? You're given an effective rate, I equals 18% annually. You need to find the nominal rate, R, when TAR interest is compounded weekly, 52 times a year. It's just like saying, how much interest should I charge per week so that by the end of 1 year I earn 18% total? Formula reminder, nominal rate R equal to K1 plus I, the 1 over K, minus 1, where R Hardy equals nominal rate of interest, I equals effective annual interest rate, K equals number of compounding periods per year, weekly equal 52. Step-by-step solution with emojis. Tashar step 1, what's given? I equals 0.18, which means 18% annual effective interest. K equals 52, since there are 52 weeks in a year. Step 2, plug into the formula. R equals 52 times 1 plus 0.18 squared 152 minus 1 stop. Step 3, solve the inside first. 1 plus 0.18 equals 1.18. 1.18, 152 equals 1.003188. This means taking 52nd root of 1.18. Step 4, subtract 1.003188. 1 equals 0.003188. Step 5, multiply by 52. 52 and 10.00188 equals 0.1658 or 16.58%. Final answer. Nominal rate equals 16.58% P to A, compounded weekly. This means if you invest at 16% nominal interest, weekly compounding a week, you will effectively earn 18% per year. Shash Banking real-life example. You're working as an assistant manager in Bank of Baroda, and a corporate client says, we need 18% yearly return, but we want to compound interest weekly for better liquidity. You can use this formula and suggest, sir, we'll offer 16.58% PA nominal rate with weekly compounding to match your 18% effective return. Your financial knowledge saves the day and earns client trust. Exam tips to remember. Use this formula when effective rate is given and you're asked to find nominal rate. Weekly means K equal 52. Effective rate is always higher when more frequent compounding. Keep calculator ready for root powers like 152. Summary table. Term, I, effective rate, 18%, K. Periods a year, 52, weekly. Formula, R equals 52 times 1 plus 0.152 minus 1, nominal rate, 16.58% PA compounded weekly. Quick recap in one line. More frequent compounding equals lower nominal rate for same effective return. Our final motivation for you. You're learning what many fear, financial formulas with confidence and joy. Stay strong. You are building skills that banking interviews, group discussions, and even real-world clients will admire. Keep pushing, future officer. You're not just preparing, you're transforming into a banking leader. Let's break down example 7 from your time value of money chapter in super easy steps with full emojis, so you understand it clearly and remember it for exams, interviews, and even banking jobs. Example 7, converting from semi-annual to monthly compounding. What's the question saying? You are told, effective rate equals 5% per year, compounded semi-annually. You have to find the nominal rate. That will be compounded monthly. Meaning in simple words, you're just converting one compounding style into another, while keeping the overall yearly returns same. Like saying I get 5% interest with semi-annual compounding. What nominal interest should I use with monthly compounding to match that? Step-by-step solution with emojis. Step 1, use the formula for compound interest. We equate both compounding formulas, P kept 1 plus r by 12 squared 12n equals P's 1 plus 0.05 squared 2 no star minus left side equals monthly compounding, right side is semi-annual compounding. So n cancels out. So we focus only on the inside. Step 2. Remove P from both sides and simplify. The equals 1 plus 0.0522 equals 1 plus r by 12 to 12 equals 1.025 squared 1.050625. Step 3. Take 12th root on both sides. 1 plus r by 12 equals star 1.050625. 1 by 12, cardio. Using calculator. 1.05625, 112 equals star 1.04133939. So 1 plus r12 equals 1.041239. Step 4. Subtract 1 to r by 12 equals 1.004139. Mine equals 0.0041239 to even. Step 5. Multiply by 12 to get annual nominal rate. R equals 0.00411239 times 12 equals 0.0494868 or 4.94868 cent. Final answer. Nominal rate equals 4.94% PA. Compounded monthly. Bank officer real-life example. Imagine you're an SBI PO in a customer service role. A customer says, I get 5% interest semi-annually from another scheme. How much interest would match that if I want monthly deposits? You apply this method and say, Sir, we can offer a nominal 4.94% PA monthly compounding. It will give you the same benefit. You look smart and gain client trust instantly. Key points to remember. Always convert effective rate equivalent nominal rate using correct compounding periods. Monthly equals divide multiply by 12. Semi-annual equals divide multiply by 2. Use roots or logarithms if needed. Quick recap in one line. 5% semi-annual effective interest equals 4.94% nominal interest with monthly compounding. Mini motivation for you. You're learning how to think like a banker, not just a student. Each formula is a step closer to your dream job, SBI PO manager, or even AGM someday. Keep grinding. Your knowledge will make you stand out in interviews, GDs, and real bank work. 1.4.3 Continuous Compounding Force of Interest. First, what does continuous compounding force of interest mean? Meaning of the heading, compounding equals adding interest to the principal so that it earns interest in the future too. Continuous compounding, interest is added every second, every millisecond, infinite times. It's like interest is growing non-stop, no break at all. Force of interest is just another name for continuous compounding. Definition in simple words with emojis, force of interest or continuous compounding is a method where interest is added at every tiny moment, continuously, without waiting for a fixed period like monthly or yearly. As K, number of compounding periods, infinity, we use continuous compounding. Formula for continuous compounding. A equals P's E that R ends N, where 9 A equals final amount. P equals principal, original amount invested. Tash star Argos equals annual interest rate in decimal form, not percent. Nesh N equals number of years. Ensh E stars equals Euler's number, 2.71828, a constant like pi but for growth. Step-by-step example. Let's say you invest $10,000, interest rate equals 6% per year. Time equals 2 years, compounded continuously. Let's calculate the amount using the formula. A equals 10,000 times E divided 0.06 times 2 stager. Chart equals 10,000 times E where 0.112, 10,000 is 1.1275, so 11,075. So with continuous compounding, your money grows to 11,275 in 2 years. Key points to remember. 1. Continuous compounding is the maximum growth method, more than monthly, quarterly, or yearly. 2. Use the formula. A equals P is E R and N for such problems. 3. E start as a constant equals 2.71828, like how pi equals 3.14159. 4. This concept is used in advanced banking, finance, and stock market models. Real-life banking example. As a bank PO, suppose a wealthy client asks, what's the highest possible return if my deposit earns interest every moment? You'll explain, sir, that's called continuous compounding, and it gives you the maximum growth possible. This shows your deep financial knowledge and impresses clients and seniors. Also helps in GDPI when asked advanced finance questions. Summary. Type formula description. Continuous compounding. A equals to P equal R ans N. Interest added every second without stopping. So when interest is added constantly and infinitely, it's continuous compounding, aka force of interest. Short motivation. You're now learning advanced finance concepts used by real bankers, analysts, and investment pros. Keep going. Every formula you understand takes you one step closer to SBIPO or a top bank manager role. Let's go, champ! 4.3 Continuous compounding, force of interest. What does this heading mean? Continuous compounding means interest is added to your money every single moment, not just yearly, monthly, or weekly, but continuously. It's also called the force of interest. This is a more advanced and accurate method of compounding, often used in financial modeling and theoretical banking. One basic concept explained in simple words. When interest is compounded continuously, it grows like it's on autopilot all the time. The formula used is A equals P E squared Rn, where A equals future amount, P equals principal, initial investment, comes from R equals annual interest rate, decimal. The N equals number of years. E equals a constant approximate 2.71828, comes from math, like pi equals 3.14. What's the meaning of E? The E here is not an alphabet, but a math constant, like pi. It helps calculate growth when changes are happening every moment. Think of it like a supercharger for your money when compounding never stops. Try out a 3, but let's understand with interesting examples. Example 8. How much should you invest to get $2,500 in 4 years at 6% continuous interest? Given A equals 2 to 500, R equals 6% equals 0.06, mine equals 4 formula. Formula A equals P times E good R N A. So 2 to 500 equals P as E 0.06 times 4 is 4. 2,500 equals P as E 0.4 P of 1.27125. Now solve for P. P equals 2,500 prior, 1.27125 is 1,966 tons approx. So you should invest 1,966 today to get 2,500 after 4 years. Hash, example 9. When will your investment double at 2.5% continuous interest? You want minus A equals 2P, double the investment. R equals 2.5% equals 0.025. Formula A equals P has either Rn, 2P EP has 0.025N, Q2 equals 0.25. Now take log both sides. Ln of 2 equals 0.025, arrow 0.6931, equals N equals 27.72 years. So it'll take about 27.72 years to double your money. Example 10. At what rate will your money become 4 times in 15 years? You want my A equals 4P, N equals 15. 4 is equals 15R, take log. How Ln of 4 equals 15R. 1.3863 equals 15R. R equals 1.3863 Spero. 15 equals 0.0924 or 9.24 cent. So an annual rate of 9.24% will quadruple your money in 15 years. Hash example 11. What is the present value of 1,000 due after 8 years at 4.2% force of interest? Given, minus A equals 1,000, minus R 0.042, my N equals 8. A equals P as E could R N dar. 1,000 P as E 0.336 equals P is 1.3995. P equals 1,000 by 1.3995 is 714.62. You need to invest 714.62 today to get 1,000 after 8 years. Hash example 12. Future value of 100 invested for 10 years at 18% continuous compounding. Given minus P equals 100 minus R equals 0.1 and N equals 10. A equals 100 is equal 1.8. Equals 100 times 6.0496 is 604.96. Your 100 grows to 604.96 cents in 10 years. Example 13. What is the force of interest if effective rate equals 8%? Formula, force of interest R equals ln1 plus I. Given I equals 8% equals 0.08. R equals ln 1.08 equals 0.07696 or 7.69. Example 14. Given nominal rate equals 12% compounded monthly, find force of interest. Step 1. Convert to effective rate. I equal plus 0.11212, can 12 minus 1 equals 1.0112, minus 1 equals 0.1268. Step 2. Force of interest equals ln 1 plus I. ln 1.1268 equals 0.1194, or 11.94 cent per cent. Example 15. Loan of $3,000 for 5 years at 14% force of interest. Find amount and effective rate. Given 9 is p equals 3000 minus r equals 0.14 minus n equals 5. A equals 3000 times e 0.7 equals 3000 times 2.013 equals 6041.269. Effective rate equals 1 is ether r minus 1 equals 0.1502 or 15.02 terziner strand. Important formulae to remember. 1a equal p is ether r n tarshang, continuous compounding. 2. Effective rate is ether r minus 1. 3. Force of interest r equals ln 1 plus I. Summary box. Concept, formula used for continuous compounding. A equal p times e squared rn, future present value. Force of interest, ln 1 plus I. Convert effective to force. Effective rate, e squared r minus 1. Convert force to effective. Where will this help in real life? In banking jobs like SBI PO, IBPS PO, knowing these concepts helps in loan structuring, investment planning, bond valuation. In interviews, if you say, I know how continuous interest works, it shows depth of finance knowledge. In group discussions, you can say, banks now use advanced models like continuous compounding to value long-term instruments, ensuring more accurate forecasting. Mini motivation to keep you going. You're doing amazing. Each concept you master builds your ladder to success, one step closer to becoming a bank PO or finance manager. Keep learning, stay curious, and remember, success doesn't come from what you do occasionally, it comes from what you do consistently. Let's keep pushing forward. Next concept, bring it on. In bank exams, interviews, and your banking career journey. 2.1.5 Techniques of time value of money. What does techniques mean here? Techniques just means methods or ways we use to calculate the value of money in the future or present. There are two main techniques we use under TVM. 1. Compounding future value method. Finding out what your money will become in the future. 2. Discounting present value method. Finding out what a future amount is worth today. Let's start the simple explanation. 1. Why people prefer money today instead of tomorrow. Imagine your friend says, I'll give you 100 now or 100 after 1 year. You'll probably choose 100 now, right? That's because 1. You can invest it and earn more. 2. There's uncertainty in future. 3. Prices may go up, inflation. So, money today is more valuable than the same money tomorrow. 2. What the text is saying, made super simple. The textbook says, 1. If you get 1 today, you will need to pay more in the future for the same 1. 2. You might accept less than 1 today instead of getting 1 in future. Let's explain this. Point 1. If you receive 1 today, in future you need to pay more. Example. If you borrow Wazoo 1,000 today from a bank, you will repay more later, say 200 after 2 years. Why more? Because of interest. This is the idea of compounding technique, used to calculate future value. Point 2. You may accept less today for 1 to be received later. Example. If someone promises to give you 1,000 after 2 years, you might say, I'll take 800 today instead, because I can use it now. This is the idea of discounting technique used to calculate present value. 3. 2 techniques of TVM explained with emojis and simple examples. And 1 compounding technique, future value, used to find out the value of money in the future. We apply interest to grow the amount over time. Formula, FV equals PV Chi 1 plus R and N, where FV equals future value, PV equals present value, R equals interest rate, N equals time, years. Bank example. If you invest $10,000 in a fixed deposit at 5% for 3 years, what will it become? FV equals 10,000, 1 plus 0.053, 11,576.25. So your 10,000 becomes 11,576.25 in 3 years. 2. Discounting technique, present value, used to find out the value of future money in today's terms. We reduce future money based on interest. Formula. PV equals FV, or 1 plus R squared N. Bank example, if someone promises 11,000 after 2 years at 5% interest, what is it worth today? PV equals 11,000 by 1 plus 0.052 equals 9,977.87. So 11,000 in 2 years is worth 977.37 cents today. 4. Diagram from your textbook. Basic valuation techniques of TVM: time value of money, compounding, future value, discounting, present value. You will use compounding to find how much money will grow in future. You will use discounting to find how much future money is worth today. Key points to remember: concept, use, formula, bank use. Compounding future value, FV equals PV times 1 plus R squared N, FDs, SIPs, investments. Discounting present value, PV equals FV, or 1 plus R squared N, EMI, bond value. How this helps you in real life and interviews. Bank PO interviews and GDs. They'll ask, what is time value of money? You can say TVM means money today is more valuable than the same amount in future. In banks, we use compounding to grow deposits and discounting to value loans and bonds. As a bank manager, you'll decide loan terms, FD schemes, and use these formulas to guide customers. Internships and MBA jobs, you'll analyze investment plans, value projects, compare financial options, all using these techniques. Technique, meaning. Formula, example. Compounding, find future value of today's money. FV equals PV times 1 plus R squared N. 10,000 in FD grows to 11,576.25. Discounting, find today's value of future money. PV equals FV, y 1 plus RN. The 11,000 after 2 years equals 9,977.37 cents today. Mini motivation for you. 90% of MBA students skip learning the real meaning behind the formulas. That's what turns a student into a bank leader. Keep going. You're not just studying for exams, you're preparing to lead an SBI, RBI, or top financial companies one day. One topic a day keeps confusion away. Let's crack this subject step by step, like a future bank manager. Deeply and simply understand the concept. Shastra 2.16, compounding, future value techniques. What does compounding future value techniques mean? Compounding means growing your money over time by adding interest on interest. Future value, FV, tells you how much today's money will become in the future if invested. It's like planting a seed, money, today and watching it grow into a tree, more money, over time with interest acting like sunlight and water. Simple definition in easy words. Compounding is a method to calculate the future value of money. It assumes that the interest you earn is reinvested, so next year you earn interest on interest. Let's break down the full explanation with emojis and examples. 1. What is compounding? Very basic. When you keep money in a bank or invest it, it earns interest. If you don't withdraw the interest, then next year the interest also earns interest. This process is called compounding. Example, you put 1,000 in a bank at 10% interest. After 1 year, 1,000 plus 100 equals 1,100. In year 2, interest is on 1,100, 110. So total, 1,100 plus 110 equals 1,210. Your money keeps growing faster each year. This is how banks calculate compound interest and how your money grows over time. 2. How does compounding work? Each year's total principal's interest becomes the principal for the next year. So it's like this. Year 1 principal earns interest, becomes year 2 principal, earns interest again. 3. Formula of future value, single cash flow. FV equals PV times 1 plus R squared N, where FV equals a future value, PV equals present value, money today. R equals interest rate per year in decimal, N equals number of years. 4. What are the 4 types of future value calculations? From your textbook, there are 4 kinds of future value scenarios. 1. Future value of a single cash flow. You invest a single amount once, like $5,000 today. You want to know its value after, say, 5 years. Bank example. You deposit $5,000 in a 5-year FD at 6% interest. FV equals 5,000, 1 plus 0.06 squared, 5 equals 6,691. 2. Future value of annuity, series of equal cash flows. You deposit equal amount every year, like 1,000 every year for 5 years. Bank example. You put 1,000 every year in an RD account for 5 years at 8%. You'll calculate the FV of each year's 1,000 and add all those. Bank 3, future value of uneven cash flows. If the amounts are different each year, like 500 in year 1, 700 in year 2, 1,000 in year 3, them. You're entering the practical part now. And this is where things start getting fun, because you're actually seeing the numbers grow using what you've learned. Let's understand. 2.1, 6.1 future value of a single cash flow. What does this topic mean? Little explanation to that point. Future value of a single cash flow means you invest a single amount once, called present value or PV, and want to know how much it will grow after a few years, called future value or FV, by applying compound interest. So this concept helps you calculate how much you'll get in future if you invest one time today. 1. Formula to remember. FV equals PV, 1 plus RE, where FV equals future value, money in the future, PV equals present value, money now, R equals rate of interest in decimal, ND equals time in years. Important concept behind the formula. This formula means your money grows each year, not only on the original amount, but also on the interest earned before. Key points to remember. If PV increases, FV increases. If interest rate increases, FV increases. If time increases, FV increases. So even small changes in these three variables can give big changes in FV. That's why banks give better returns when you invest early and for long time. For real-world bank example. A customer wants to put 100,000 in a fixed deposit at 7% for 5 years. As a bank officer, you must use this formula to tell them the future value of their FD. It helps you make financial decisions for customers or yourself. Hacktrap examples with emojis and clear steps. Example 1. FV of 1,000 at 10% for 7 years. Step 1. PV equals 1,000, R equals 10% equals 0.1 euro, N equals 7 years. Step 2. FV equals 1,000's 1 plus 0.107 equals 1,000 times 1.17 equals 1,000 times 1.95. FV equals 1,950 plus, meaning 1,000 will grow to 1,950 in 7 years at 10% interest. Example 2. FV of 5,000 at 11% for 9 years. Step 1. PV equals 5,000, R equals 11%, equals 0.111, N equals 9. Step 2, FV 5,000 times 1.1129 and 2.56. FV equals 12,800 N. Example 3. FV of 50,000 at 16% for 3 years. Step 1, PV equals 50,000, R equals 16%, equals 0.16, N equals 3. Step 2, FV equals 50,000 times 1.163 equals 50,000 times 1.56. FV equals 78,000, example 4, textbook example. Govern's bank deposit. Data, PV equals 10,000 times R equals 8% equals 0.8 to N equals 8 years. Step 1, so FV equals 10,000 times 1.088 equals 10,000 is 1.8509. FV equals 18,509. Meaning, Govern's 10,000 will grow to 18,509 in 8 years at 8% annual compound interest. Where you'll use this in real life and bank PO interviews. In bank PO interviews or group discussions, you may be asked, how do banks calculate maturity amount of deposits? You can explain this formula and how it's used in fixed deposits, recurring deposits in more advanced form, future value of savings plans. As a probationary officer, you'll help customers choose best deposit options, calculate returns, build financial plans. This topic also helps you if you later become a wealth manager or loan officer. Check, quick summary table, term, mean example. PV, present value, 1,000 invested today. R, interest rate 10% equals 0.10, N, time years, 7 years, FV, money in future, 1's 950 after 7 years. Formula, FV equals PV times 1 plus R twit N. Mini motivation before you move on. You're learning how money grows over time. This is not just theory, it's real-life banking knowledge. These small formulas are big tools in your future career. Winners don't wait for opportunities, they prepare for them. You're preparing like a true banker and future officer. 2.16.2 Future value of uneven cash flow. What is it? Simple idea. Sometimes you don't invest equal amounts every year. Maybe you invest more in 1 year, less in another. This is called an uneven cash flow stream. This concept helps you calculate the total future value of all those uneven investments using the compound interest formula for each individual year's investment. Formula you need to know. FV equals R rings 1 plus R at n minus 1 plus R2 as 1 plus R squared n minus 2 plus Rn true. Where symbol, meaning, becomes FV, future value, total value at end, R ring, R2, cash invested in year 1, year 2, etc. Interest rate per compounding period, N, total number of periods, years. Each cash flow grows for a different number of years, so we compound each separately. And share steps to solve easily. 1, 2, 3 method. 1. Write down all the cash flows for each year. 2. Apply FV formula to each separately. 3. Add them all to get total future value. Real-world use in banking. In banks, customers often ask, if I invest different amounts each year, how much will I have after 5 years? As a bank PO, you will use this formula to help. Calculate maturity value of variable recurring deposits. Plan long-term goals like car purchase, wedding, home, etc. Suggest best savings schemes to customers. Example 17. Car purchase planning by Mr. A. Given, year investment compounded semi-annually at 9%, i.e. 4.5% per 6 months. 1,500 for 4 years, 8 half years, n minus 1, on. 2 equals 6, 2, 3,000 for 3 years, 6 half years, n minus 2 not 2 equals 4. 3, 2,200 years for 2 years, 4 half years, n minus 3, 2 equals 2. 4, 3,000 for 2 half years, and 4 R2 equals 0, 0. Step-by-step FV calculations, R equals 9% yearly equals 4.5%, semi-annual equals 0.045. Now FV equals 1,500 times 1.045 square. 6 that's 1,500 times 1.32D equals 1,953.3. Times 3,000, 1.0454 equals 3,000, 1.1925 half equals 3,577.5. Minus 2,200, 1.045's 2 equals 2,200 and 1.920 equals 2,042.4. 3000 1.045 scores. 0 equals 3000 plus 1 equals 3000 0. Final FV equals 1953.3577.5 plus 2402.4 plus 3000 equals 10,933.2. Example 18. House painting for Diwali festival. Mr. A invests $2,500 every year for 4 years at different interest rates. Period. Investment interest rate annual. 3,000. 1. 2,500. 3%. 2. 2,500. 4%. 3. 2,500. 5.5%. 4. 2,500 5%. Step-by-step FV calculation. Period 1, n-1 equals 3. 2,500 times 1.03, 3 equals 2,500 times 1.09, 3 equals 2,731.75. Period 2, n-2 equals 2. 2,500 times 1.042, 2,500 times 1.082 equals 2,704.0. Period 3, n-3 equals 1. 2,500, 1.55 1 equals 2,637.5. Period 4, n-4 equals 0. 2,500 bundled 1 2, 500.0. Final FV equals 2,731.75 plus 2,604 plus 2,637.5 plus 2,500. It's 10,573.25. Key takeaways for Bank PO exams and career notes. Uneven cash flow problems appear in Bank PO Quant section as investment or time value of money questions. Very useful when clients ask, how much will I have in 4 years if I invest different amounts each year? Be ready to break down each cash flow, apply correct compounding rate, add all FVs carefully. Quick recap table concept use future value of uneven cash flow. When investments differ each year. Formula. FV equals R1 1 plus R n-1 plus R2 1 plus R squared n-2 plus. Used for car plans, weddings, home goals, customer planning. Appears in banking, finance jobs, MBA finance exams. Mini motivation for the day. Compound interest is the 8th wonder of the world. Master it, and you'll master money. It's a simple explanation of 2.1.6.3 future value of annuity series of equal cash flows with emojis, examples, and summary for easy understanding. What is annuity? An annuity is a series of equal cash flows, like savings or investments, made at regular intervals over a fixed period of time. Example: you deposit $1,000 every year for 3 years. This is called an annuity of $1,000 for 3 years. Hashtag formula to calculate future value of annuity, FVA. FVA equals A, 1 plus R, 1, S1 RR, where in its FVA equals future value of annuity. A equals regular payment, amount deposited each time. R equals interest rate per period. N equals number of periods. Example 19, simple annuity. You deposit $10,000 every year for 5 years. Interest rate equals 10% annually. FVA equals 10,000. 1 plus 0.15 is 1. 100 is 1 equals 10,000 times 1.611 times 1.11 equals 10,000 times 6.11 equals 61,100 ton. Example 21. Find how much to deposit each year. You want $3,000 after 10 years. Interest rate equals 10%. You want to find A, annual deposit. Use the formula backwards. And you want A equals FV, R1, then 1 plus R, n-1 by R. That equals 15,923.62 per year. A share growing annuity when payment increases every year. Formula, F via A equals A, 1 plus I squared n is 1 plus G at I with G, where A equals initial payment, I equals interest rate, G equals growth rate of payment, N equals number of years. Example 22, growing annuity. Salary equals 5 lakh, increases 5% yearly. 20% invested equals 1 lakh starting, rate of return equals 12%. Time equals 15 years. FVA equals 1,000, 1.12 square 15, 1.25 for 1.05, 12.059. T equals 1,000 has 5.473 digits house, 2.078, cool point to Rosos, 48,005 den pardon. Summary table, concept, description, Rexon. Annuity, regular equal payments at fixed intervals. FVA formula. A 1 plus R, n minus 1 by R. Growing annuity formula. A is 1 plus I n as 1 plus G squared n, I minus G. Key inputs. A equals a payment, R by equals interest rate, G equals a growth rate, N equals number of years. Would you like me to create chapter name 2.1.6.4 Future value of multiple flows. Module, time value of money. Subject, financial management. Let's understand this concept from the basics with full emojis and clarity. What does future value of multiple flows mean? This topic talks about situations where you invest different amounts of money each year, instead of equal yearly payments like annuity. This is called multiple cash flows. Future value, FV, means how much your total investment will become in the future after interest is added. Let's start with a simple definition. Definition: when investments are made in unequal amounts over different years, we calculate the future value of each investment separately using compound interest and add them up to find the total future value. This method is called calculating the future value of multiple cash flows. Why is this important? As a bank PO or finance manager, you'll often come across investment plans where people invest varying amounts at different times. You'll need to calculate how much these investments will be worth in the future to advise them correctly. Let's break it down with a fun example. Example 1. An investor deposits $1,000 in year 1, $2,000 in year 2, $3,000 in year 3. Interest rate equals 12% P/A. Find the future value at the end of year 3. Step-by-step calculation. 1,000 is invested for 3 years. FV equals 1,000, 1.122 equals 1,000 times 1.254 equals 1,254. Style 2,000 is invested for 2 years. FV equals 2,000 times 1.12 square root. 1 equals 2,000, 1.12D equals 2,240. 3,000 is invested for 1 year. FV equals 3,000, 1.12 squared. 0 equals 3,000 times 1.00 equals 3,000. Total future value equals 1,254 plus 2,240 plus 3,000 equals 6,494. General steps to calculate future value of multiple flows. 1. Identify the amount invested each year. 2. Note how many years it will stay invested until the final year. 3. Apply future value formula for each amount. FV equals amount 1 plus R squared N, where minus R equals interest rate. N equals number of years it will be invested. 4. Add all individual FVs to get total future value. Textbook example explained in simple way. Example 2. A LOX investment. Investments. 500, 1,000 year 2, 1,500 year 3, 2,000 year 4, 2,500 year 5. Interest rate equals 5% PA. Find value at end of year 5. Year, amount. Years till year 5, FVF at 5%, FV 1.103. 1, 500, 4, 1.216, 608, 2,000, 3, 1.158, 1,158, 3, 1,500, 2, 1.103, 1,654.5. 4, 2,000, 1, 1.05, 2,100. 5, 2,500, 0, 1.00, 2,500. Total FV equals 608 plus 1,158 plus 1,654.5 plus 2,100 plus 2,500 equals 8,020.5. Key points to remember. This method is for unequal investments over time. Apply compound interest to each separately. Add all final amounts to get total future value. Use correct FVF, future value factor, or formula. FV equals P times 1 plus R square. Banking and real-world connection grow. As a bank officer or assistant manager, you will help clients with investment plans, FDs, SIPs, bonds. Use this concept to show how their irregular deposits grow. Design custom investment options for HNIs or small savers. Handle loan repayments with irregular EMI schedules. In group discussions or interviews like SBIPO, if asked about how do you handle multiple investment scenarios, you can explain this method confidently. Quick summary. Future value of multiple flows, FV of each investment at its duration added together. Use compound interest formula separately for each cash flow. Helps in real-life finance and banking work. Common in SIPs, staggered deposits, FD ladders, etc. Mini motivation boost for you. You're doing great. Keep going step by step. You're mastering real financial tools used by professionals in banks, corporates, and even stock markets. One topic at a time makes you unstoppable. Your PO seat is waiting. Stay focused and crack it. Time value of money. Subject Financial Management, MBA, second semester. What does discounting present value mean? Meaning of the heading before starting explanation. Discounting means finding out how much a future amount is worth today. Present value, PV, means the value right now of money that we will receive in the future. It's like asking, if I will get one Thora 1000 next year, how much is that Thora 1000 worth today? This method is super important in finance, banking, and investment decisions, and is opposite of compounding. 1. What is discounting? Definition in simple words. Discounting is the process of calculating the present value PV of a future payment or a series of payments by applying a discount interest rate. Since money earns interest, one today is worth more than one tomorrow. Just 2. Compounding versus discounting. Let's keep it super simple. Compounding. You know the amount today, you want to find its future value. Discounting. You know the amount in future, you want to find its present value. Formula for discounting. PV equals FV, 1 plus R, where PV equals present value, FV equals future value, R equals interest rate per year %, N equals number of years. Cash to 3, easy example, bank related. Imagine you're a future bank probationary officer and a customer says, I will deposit $10,000 in 2 years. What is the value of that $10,000 today if the bank pays 10% interest? Solution. PV equals 10,000, y 1 plus 0.10 squared equals 10,000 par square. 1.21 equals 8,264 approx. So 10,000 in future is worth only 8,264 today. 4 PV relationships with other variables. PV increases when FV increases. If future value is more, naturally present value is more if R and N are same. E.g., 2,000 after 1 year is worth more today than 1,000. PV decreases when interest rate increases. Higher the interest, lesser you need today to reach the same future amount. E.g., if bank gives 15% interest, you need less money today to reach 10,000 in future. #E, PV decreases when time increases. Longer the time, lower the present value because money earns interest for more years. E.g., 10,000 after 10 years is worth much less today compared to 10,000 after 1 year. 5. Types of discounting situations. These are like 4 different shapes of PV calculation. 1. Present value of single cash flow. One-time future payment. 2. Present value of annuity. Equal payments every year, like EMI pension. 3. Present value of uneven cash flows. Right? Different amounts at different times. 4. Present value of perpetuity. Fixed payment forever, like perpetual bonds. Short and simple bank-related example. A loan customer will pay $5,000 after 2 years. If your bank earns 8% interest, what is PV? PV equals 5,000, 1.08 squared equals 4,287 approximately. So as a bank manager, you know what this 5,000 is worth today in decision-making. Summary. Concept, meaning, discounting, finding today's value of future cash. Formula. PV equal FV, 1 plus R, and when used in loan assessment, investment decisions, project evaluation. Opposite of compounding. PV decreases as interest rate R or time N increases. As a bank PO or finance manager, you will evaluate loan proposals using present value, decide if investment projects are profitable, help customers understand value of deposits or retirement plans. This concept is fundamental in banking exams, GDs, interviews, and job roles. Quick motivation. You're doing a great job staying consistent. Keep going. 1 topic a day, success on the way. Remember, winners are not those who never fail, but those who never quit. You'll be a successful bank officer, finance pro soon. Great. Let's now understand a very important and basic concept. #SHUT 2.17.1 Present value of a single cash flow. Heading meaning first. Present value means how much a single amount of future money is worth today. Single cash flow means only one payment in the future, not repeated every year. This is a foundation concept in finance and banking. used to make decisions like giving loans, accepting deposits, or comparing investment options. Why present value is less than future value? Because of opportunity cost. Opportunity cost means the benefit you lose when you choose one option over another. For example, you can get $1,000 today and invest it to earn interest, or you get $1,000 after 2 years, but you miss earning interest for 2 years. So the $1,000 received after 2 years is worth less today. The more you wait, the more interest you lose, so more value is lost today. 2 formula to calculate PV of a single cash flow. PV equal FV, Y1 plus where's, where PV equals present value, FV equals future value, psi you'll get later. Interest rate per year percent, N equals number of years to wait. 3 example from your textbook. Question, a person will receive $3,000 after 8 years. Rate of interest R equals 10%. Find present value PV. Shash step-by-step solution. Formula, PV equals FV by 1 plus RN. Substitute values. PV equals 3,000, 1 plus 0.10. PV equals 3,000, 1.10. PV equals 3,000, 2.1436. PV equals 1,399.17 and approx. Task 4, easy bank-related example. As a future bank officer, you are evaluating a customer who promises to pay $10,000 after 5 years. Your bank wants 10% interest. PV equals 10,000 by 1.10 equals 10,000 by 1.6105 equals 6,210.60. So today, 10,000 after 5 years is only worth 6,210.60 today. This helps you decide if it's worth giving a loan or not. 5 important points to remember. Longer waiting equals lower PV. Higher interest equals lower PV. PV-FV always, due to interest loss, used in banking, investments, and business decisions. Summary table. Concept, meaning, PV of single. Great. Let's now understand a very Concept 2. Decide if future payments are worth it today. Approve PV equals FV by 1 plus R Hain, used for loans, deposits, investment decisions. PV goes down when R or N, opportunity cost, interest you lose by waiting. Real life and career connection. As a bank PO or assistant manager, you'll regularly use this concept to decide if future payments are worth it today. Approve loans and EMI plans. Estimate present worth of long-term contracts. In SBI PO interviews or GDs, they might ask, how do banks calculate the value of money today from future receipts? Now you can answer confidently using PV. Quick motivation to keep going. You've now mastered one of the core financial tools used by professionals. Keep learning one step at a time. Success in SBI PO and MBA is waiting for you. Small progress every day leads to big results. Next step, ready to go for the next concept? Cash flow streams. Heading meaning first. Uneven cash flow means you're receiving different amounts of money at different times. Present value here means what is the total worth today of all those future amounts? This is very useful in real-life finance, like evaluating a business project or calculating how valuable a customer's future payments are. What is uneven cash flow stream? Unlike an annuity, where cash is same every year, here the cash is not fixed each year. For example, year 1, 1,500, year 2, through 3,000, year 3, 2,200, year 4, 3,000, 3,000, and all have different interest discount rates. Tanash 2 formula to calculate PV of uneven cash flows. We calculate the present value PV of each cash flow separately and then add them. Formula PV equals R1, 1 plus R1 plus R2, 1 plus R2 plus R3 is 1 plus R3Q plus RN for 1 plus RN, where minus RVN R2 equals payments in each year, RWN R2s, equals interest rates in each year, and equals year number. Let's solve the given example. Year, cash flow R, interest R, barter, 1, 1,500, 3%. 2, 3,000, 4%. 3, 2,200, 5.5%. 4, 3,000, 5%. Step-by-step solution. PV meek 1,500 where 1 plus 0.03, 1,500, 500 bar graph. 1.03 equals 1,456.31s. PV2 equals 3,000 hard 1 0.44 squared equals 3,000, 3,000, 1.816. 2 equals 2,773.67. PV 200 1,10554 equals 2,200 1.17557 was 1,073.555. PV figure 3,000 1 plus 0.05 card equals 3,000 parsed 1.2155 2,468.11. Total PV 1,456.31. Plus 2,773.67, plus 1,073.525, plus 2,468.11 and 8,571.644. You're working as a bank PO, and a customer agrees to repay a loan like this. Year 1, 5,000 at 5%. Year 2, 3,000 at 6%. Year 3, DeRose 4,000 at 7%. You calculate present value for each and see if the total PV is equal to or greater than the loan amount given today. This helps you decide whether to approve the loan or not. 5 important points to remember. Each year has different cash and different rate. Calculate PV of each year separately. Add them to get total PV. This is used in projects, EMIs, investments. Concept, meaning uneven cash flows, cash amounts and interest change each year. Formula, PV equals R1 where 1 plus R1, N plus R2 where 1 plus R2 were plus, used for projects, loan evaluations, investment worth. PV goes down when R or time increases. And real life and career link. In interviews or GDs, they may ask, how will you evaluate a project with variable returns each year? You'll now say, I'll use the present value of uneven cash flows technique to find today's worth of future payments and compare it to cost. In bank PO role, this helps in evaluating loans with variable EMIs, investment proposals from customers, business loan repayment plans. Quick motivation to keep going. You just learned one of the most practical tools in finance. Every number you master today takes you one step closer to your dream banking career. Stay consistent. You're on your way to become a brilliant finance pro and future bank manager. Absolutely. Let's dive deep into this very important and practical concept from Financial Management Time Value of Money TVM. I'll break it down from scratch with full emojis, real-life banking use, and easy formulas. Let's make this super simple and fun to learn. 2.1.73 Present value of annuity, series of equal future cash flows. What does the heading mean? Present value PV equals what is the value today of money you'll receive in the future? Annuity equals a fixed equal amount of money received regularly, like every year month. So, present value of annuity equals how much is that series of future equal cash flows worth right now? Why this is important. In real life, especially banking, people get or pay equal money every year, like EMIs, fixed deposits, loan repayments, pension schemes, investment in contracts. So you must learn how to calculate their present value to compare options and make smart financial decisions. Simple example to understand. Let's say a company gives you 2 options. Option 1, pay $2,500 right now. This is already in present value, so no changes needed. Option 2, pay $900 at end of each year for 3 years. Now, you want to compare which is cheaper in today's terms. To do that, we calculate the present value of $900 paid each year using a discount rate of 10%. How do we calculate present value of an annuity, PVA? Here's the formula. PVA equals A, 1 minus 1 plus R minus N R, where PVA equals present value of the annuity. A equals amount received / paid each period. R equals rate of interest per period as decimal. N equals number of periods years. Now let's solve the given example 26 step by step. You are receiving $50,000 every year for 5 years. The interest rate discount rate is 8%. Step 1, write the formula. PVA equals to A minus 1 plus R, but ends by R. Step 2, plug in the values A equals 50,000, R equals 8%, equals 0.08, N equals 5. Step 3. Solve inside the formula. 1 plus r n equals to 1.085 equals 1.4693. Now, PVA equals to 50,000, 1 minus 1 by 1.4693 by 0.08 equals 50,000 times 1 minus 0.607 by 0.08 equals 50,000 times 0.3193 by 0.0. Absolutely! Let's dive deep into this very important and practical concept from financial management, time value of money. $900 paid yearly, 3 years. Let's calculate PV of option 2. Year 1, 900 pars bar 1.101's 818.108 equals 50,000, 3.9915, 199,562 feet. So what does this mean? Getting 50,000 every year for 5 years is equal to getting 1,999,562.50 cents today at 8% interest rate. This is your present value. Back to the previous option example. Option I, 500 paid today. Option 2, 900 paid yearly, 3 years. Let's calculate PV of option 2. Year 1, 900 pars bar 1.101's 818.118. Year 2, 900 by 112 equals 743.80. Year 3, 900 by 1.123 equals 676.18. Total PV at 18 plus 744 plus 676, now 238. So option 2 is better than option 1 because 2,238, 2,500. Key points to remember. 1. Annuity equals equal payments at regular intervals. 2. Present value shows what future cash is worth today. 3. Use formula. PVA equals A as 1 minus 1 plus R minus N, R. 4. Compare investment options using PV to choose the cheapest or best return. 5. This is used in banking, loans, FD analysis, pension plans, etc. Bank, PO interview, or work example. Let's say a loan customer will pay those $20,000 every year for 5 years. As a probationary officer, you'll use this formula to calculate PV and compare it to the loan amount. If PV is less than what the bank gives, you may reject the loan or increase interest rate. This helps in making sound lending decisions, just like a bank manager would. Term, meaning annuity, equal cash flows over time, PV, today's value of future money, formula. PVA equal A, 1 plus R, N, Y, R. Usage. Loans, EMIs, FD returns, investments. Exam tip, practice example sums and understand logic. Mini motivation. You're doing amazing. Each concept you learn is making you stronger for SBI PO, MBA exams, and your dream role as a bank officer. Keep going. Great bankers are not born. They are built one formula at a time. Subject, financial management. Module 2, time value of money. Chapter 2.1.7.4, present value of growing annuity. Meaning of the heading, present value of growing annuity. Present value, PV, means the current worth of money you will receive or pay in the future, considering interest rates, discounting. Annuity means a series of equal or increasing payments made at regular intervals, like yearly or monthly. A growing annuity is when these payments increase each year by a fixed rate, growth cent. For example, $3,000 in year 1, $3,150 in year 2, $3,307.50 in year 3, and so on. Simple explanation. When you receive or deposit increasing payments every year, like in a recurring deposit, the present value helps you know how much it's worth today if you bring all those future payments to today's value using a discount rate, interest rate. Formula to use. If growth rate G is not equal to interest rate R, PV equals CR and FG times 1 plus G, or 1 plus R square N, where CCFV equals cash flow in first year, so R equals interest rate discount rate. G equals growth rate of cash flows, N equals total number of years. Special case, if Tesh R equals G, the formula becomes invalid. You'll be dividing by 0. So we use Stoddard PV equals C times F fund times N 1 plus R. Example, textbook example 27 explained. Data given. A person opens a recurring deposit for 10 years. First deposit, $3,150, minus each year deposit grows by 5%. Interest rate R equals 12%. Growth rate G equals 5%. N equals 10 years. Step-by-step solution. We use the formula PV equals times F1 bar R minus G. 1 minus 1 plus G, 1 plus R, equal to N. Step 1. Put values in the formula. PV equals 3,150, 0.12 minus 0.05, against 1 minus 1 plus 0.05, 1 point. Subject, financial management. Module 2, time value of money. Chapter 2.1.7.4, present value of growing annuity. Meaning of the heading, present value of growing annuity. Subject, financial management. Module 2, time value of money. Chapter 2.175, present value of perpetuity. Meaning of heading, present value of perpetuity. Perpetuity means a series of cash flows that continue forever without end, like a never-ending EMI or interest income. Present value, PV, means how much that forever income is worth today using interest rates. Easy definition. Perpetuity is a constant and identical cash flow, same amount every year, that goes on forever. Present value of perpetuity tells us how much this stream of money is worth today. We use this when the payments go on for infinite time. Formula to use. PV equals annual cash flow rate of interest, where PV equals present value. Annual cash flow equals same amount received every year. Rate of interest R equals discount rate or return rate in decimal. Important note, the full formula with 1 plus R, quoted, etc. is like this. PV equals CF by 1 plus R plus CF by 1 plus R quoted plus CF 1 plus R plus up to infinity. But since it goes on forever, the math simplifies beautifully too. PV equals CF by R, very easy to use. Example from your textbook. Situation. You're getting 2,500s every year forever, like from a trust fund or donation, or bond income. Required rate of return equals 12% or 0.12. 2. Apply form equals 2,500 to 0.12 equals 20,833.33. So if someone offers you this perpetual income stream, the value of that deal today is 20,833.33. Real life example, Bank PO style. Suppose you are a bank officer and a customer asks, if I deposit 1,000 and earn 4% interest forever, how much income will I get each year? You reply, Sir, ma'am, you will get 40 every year forever. That's a perpetuity. Also, when you assess perpetual bonds or pension plans, this concept helps to find out their real worth to the bank and the customer. Key points to remember. Perpetuity equals same cash flow forever. PV equals annual cash flow interest rate used in bonds, perpetual deposits, trusts, etc. Works only when cash flow is constant and never ending. Helps compare long-term income options. Concept, meaning perpetuity. Constant cash flows forever. Present value PV, today's value of future cash flows. Formula, PV equals annual cash flow. Interest rate, example, 2,500 a year at 12%. PV equals 2,833 cents. real use, bonds, trusts, pensions, long-term deposits. Use in interviews in SBIPO or IBPSPO interviews. If you're asked, what is perpetuity and where is it used? How do you value a perpetual income stream? You can confidently say, is a fixed income forever, and its value today is calculated using PV equals cash flow rate. It's often used in bonds or fixed deposits that yield interest indefinitely. As a bank PO or assistant manager, you might assess retirement products, perpetual bonds, or charitable trust returns. This formula will help you give correct advice to customers. Short motivation. You're building your brain like a banker. Just like a perpetuity never ends, let your motivation be endless too. Stay sharp, stay focused, and you'll be writing SBIPO on your chest very soon. Let's tackle the next topic together. 2.1.8 Concept of annuity due. First, what does annuity due mean? Let's understand the heading first. Annuity equals a fixed amount of money received or paid every year or month, etc. Due means immediately or at the beginning of the period. So, annuity due simply means an annuity where the cash flows, money in or out, happen at the beginning of each period instead of the end. Simple explanation of the concept. 1. Usually, we assumed money is received or paid at the end of every period, like year-end. That is called ordinary annuity. Example, EMI paid at end of each month. 2. But annuity due means money is received or paid at the beginning of each period. Example, house rent that you pay at the beginning of each month. 3. In both types, number of periods N stays the same, but their formulas differ because of timing of payment. 4. In annuity due, since money comes earlier, it earns more interest. That's why we multiply the formula with 1 plus R star to adjust it. Formula for future value of annuity due, FVD. FV equals A is 1 plus R squared N times 1 plus R sine, where A equals annuity amount, money per year, R equals interest rate per period, N equals number of years. Example 30, future value of annuity due, question. A person wants $50,000 after 10 years. He deposits money at the beginning of each year. Interest equals 10% PA. Find how much he deposits every year. Step by step. FV equals 50,000, R equals 10%, equals 0.10, N equals 10. Formula. FV equals A is 1 plus square N minus 1 over R, hence 1 plus R. Plug in values. 50,000 equals A is 1.1, 110 minus 1.1 is 1.1. 50,000 equals A is 15.94 times 1.50,000 equals A is 17.534. A equals 50,000 by 17.534, 2,853.188. So, person deposits 2,853.88 every year, beginning of each year, star for 10 years. Hash formula for present value of annuity due, PVAD. PV equals A equals 1 does 1 plus R minus N, divided by R times 1 plus R tau. This formula tells us the present worth of receiving money starting now and for N years at the beginning of each year. Example 31, present value of annuity due. Question. Rouse 1,000 is received at the beginning of next 4 years. Interest equals 6%. Find present value. Step by step. A equals 1,000, R equals 6%, equals 0.06, N equals 4, PVAFRN equals 3.465 from table, PV equals 1,000 times 3.465 times 1 plus 0.06, minus PV equals 1,000 times 3.465, 1.06, and PV equals 3,673. So the present value of this annuity due equals 3,673. Key points to remember. 1. Annuity equals payment happens at the beginning of every period. 2. Ordinary annuities payment happens at the end of every period. 3. FV and PV formulas for annuity due are multiplied by 1 plus R to adjust for early payments. Used in rent, leases, Great! Let's break down the concept of loan amortization in a super simple and interesting way, full of emojis, examples, and real-life banking connection, just like you requested. You're on the right track to mastering financial management and cracking bank PO exams. Let's do this. Concept name, 2.1.9 Loan amortization, meaning amortization means paying back a loan in equal parts, EMEs, over time that includes both interest and principal. What is loan amortization? When you take a loan, you don't return it all at once. Instead, you pay small equal installments, EMIs, every month or year. These EMIs include two parts: interest, cost of borrowing, principal, the original loan amount. This process of repaying the loan slowly in parts is called loan amortization. Cash, real-life example. Before going to formula. Suppose you take a loan of 10,000 pesos at 10% interest to buy a car or start a business. But you say to the bank, I'll start repaying from third year onwards. That means for the first 2 years, no EMI is paid. Bank will add interest for the delay. After 2 years, you'll start paying equal annual payments. These payments will now cover principal amount, interest added due to delay. Step-by-step loan amortization calculation. Step 1. Calculate future value, FV, at the end of delayed period. Formula FV equals PV times 1 plus R squared N. Nice. PV equals present value, loan taken, equals 10. R equals interest rate is 10%, equals 0.10. As N equals number of years delayed equals 2. FV equals 10,000 times 1.10 squared. 2 equals 12,000, 10,000. You now owe 12,000 10,000 due to interest buildup. Step 2. Convert that amount into equal annual payments. Formula PV equals A and PVAF are N star. A equals PV by PVAF. PV equals 12,000 and 10,000. R equals 10%. N equals 6 years. You'll repay over 6 years. From table, PVAF 10% 6 equals 4.355. A equals 12,000 10,000 Shrey. 4.355 equals 2,077,840 per year. So every year for 6 years, you'll pay 2,077,840 cents. Example 32 simplified. Loan, 10,000, interest rate, 14%, 10-year, 5 years. Use formula PV equals R and PVIF RN. PVIF 14% 5 equals 3.43. R equals 10,000, 3.433, 2,009, 1,290 per year. Now for monthly EME, EM equals 2,191,290. 12 equals 24,274 per month. Hacked loan amortization schedule simplified. Year interest 14%, EME, principal paid, loan balance 1. 1 davers 4,219 and 2 1 da 290 Z 8,048,000 N. 2 1,017 and 2,990 1,072,070 6,476 40. 3 94,670 2,991,209 2,196,620 4,079,620. 4 67,150 2,91,290 2,055 507 2,520 by 0. Each EME pays interest first, then the remaining goes toward principal. Example 33, monthly EMI. Loan equals 8,000, interest equals 1.25% per month. EMI equals 12 months. Use EMI formula. EM equals R plus R, 1 plus R squared, and 1 plus R minus 1 star. Here, P equals 8,000, R equals 0.0125, N equals 12. EMI equals 727. Example 34, TV purchase case. TV, price equals 13,000, down payment equals 3,000, balance equals 10,000, 10-year equals 4 years, interest 14% per annum, compounded annually. First, we calculate EMI using the formula. Then draw the amortization schedule like previous examples, year-wise interest, principal paid, and balance. Summary time, easy revision. Key concept, meaning position, loan amortization. Paying back a loan in regular EMIs that include principal and interest. EMI formula. EM equals P R 1 plus R squared N by 1 plus R squared N minus 1. PV equals A as PVAF, or FV equals A hence FVAF. A chart showing how much interest and principal is paid in each EMI. How this helps in real life and bank PO career. In bank PO interviews, understanding loan structures, EMI calculations, and interest is essential because you may offer loans to customers as a bank officer. You'll explain EMI terms, amortization, etc. to customers. You'll assess the risk of giving loans. You'll help create repayment plans for individuals' businesses. During internships or as assistant manager, you'll use this in credit, finance, or operations departments. Small motivation for you. You're not just studying formulas, you're building the mindset of a future bank officer. Even the best officers once struggled with basics. You're doing amazing by asking for clarity. Keep the fire alive, you're already on your path to success. Success is the sum of small efforts, repeated day in and day out. Let's keep going. Next concept awaits. Ready for the next topic? Just send it and we'll break it down together. Thanks. Let's fix and clearly explain example 34 to start with the correct loan amortization schedule, because the table given has some inconsistencies, like last balance not becoming zero. We'll go step by step and explain everything like a teacher, in simple words with emojis and a complete final table. Example 34, TV loan with loan amortization schedule. Given, cost of TV equals 13,000, down payment equals 3,000, balance loan PV equals 13,000, to 3,000 equals 10,000. Interest rate R equals 14% annually. 10-year N equals 4 years. Equal annual payments equals was? Find it using PV equals A as PVAF. Step 1, calculate equal annual payment. Formula, PV equals A as PVAF RN. Star PVAF 14%, 4 years equals 2.91371 from table. Shush 10,000 equals A is 2.91371. 10,000 bar 2.91371 equals 3,432.05. So each annual payment 3,432.05 is then 5. Hasher step 2, prepare loan amortization table. We will show beginning balance, annual installment is 3,432.05. Interest equals 14% of beginning balance. Principal equals installment interest. New balance, beginning. Principal loan amortization schedule, year. Beginning balance, installment. Interest at 14%, principal paid, ending balance, 7,967.95. 1, 10,000, 3,430.05, 1,400, 32.5, 7,967.95. 2, 7,967.95, 3,432.5, 1,105.51, 2,160.5, 5,651, 3, 5,651.41, 3,432.5, 791.2, 2,640.85, 3,004, 3,010.10.6, 3,432.5, 421.48, 0.00. Loan fully paid off after 4 years. Final summary, easy revision, loan taken equals 10,000. Interest 14% per annum equals 4 years. Equal annual installment equals 3,432.05. Loan amortization schedule shows how each payment reduces interest and principal. Real-life banking link, PO interview tip. As a bank PO, you will explain loan repayment schedules to customers, calculate EMIs using formulas or software, prepare amortization tables for home car loans, help design repayment plans for personal and business loans. This example builds your core concept plus practical skill for banking roles. Would you like me to create a PDF handwritten style summary or diagram style table for this example?